One more has to join. So are you clear about these positions? Once again, give me your quick reaction. Any confusion left in selecting the position of object? No confusion, right? So the next topic is simply the ray diagrams. We'll start with the convex lens. Ray diagrams of a convex lens. We know the positions already. We will come from very far distance. That is what the first situation is: object placed at infinity distance. So in this case, are you showing any object on the principal axis? Are you showing the object on the principal axis? Answer me. Abhinay?
No.
No. Right? So we are not showing the object on the principal axis. So directly you can complete your procedure, drawing the principal axis on the horizontal paper, then identifying its pole, cut the lens at midpoint, then identify its focal points and center of curvatures. Then here we are not showing in this case any object on the principal axis, just directly we are considering the parallel beam of light rays. Can anybody, what happens if parallel beam of light ray is incident on a convex lens? Answer.
They converge at a point.
Right, they are going to converge at a common point after refraction. So all the light rays are going to pass through the optic set, focal point after refraction. So they converge at a common point called focus. So at that place, you got the image. What the characteristics you can write for the image? Where the image is formed? Where the image is formed? Is it real image or virtual image? How do you decide? This image characteristics I want. What about its size? No size. It is point size. Okay. Then position. Position is at F1. Then is it a real image or virtual image? It is a real image because it is given by converging of light rays. Right? Real image is given by converging of light rays. Then is it inverted or erect? Which is correct? We cannot decide because it is point size. We cannot decide. Right? So we can write the characteristics of the image as follows. Real image, it is not decided. It is inverted or erect. Then size is point size. Finally, its position is focus. Clear? Characteristics how I written. By the converging of light rays, that image type is real image. Then we'll go for the second possible position. What is second position? Anybody? I'm coming from very far. Second position. It is beyond the center of curvature. Beyond the center of curvature. So draw the principal axis first, identify its pole, then draw the respective lens, identify its respective focal points and center of curvatures, then show your object on the principal axis. So what the logic I said, use your scale and draw the height of the object above the principal axis equal to the width of the scale. Immediately you can complete that parallel light ray from the top of the object before removing your scale. Then second ray. What is second ray? The ray passes through the optic center. So a ray passing through the optic center remains undeviate. So you can extend directly. Then first ray, this parallel ray, parallel to the principal axis after refraction, it will be converged. So extended to meet the second refracted ray. So they are going to be converged. So I got a point, converging point. So what type of image I will get? Real image. So perpendicular drawn onto the principal axis. So this is our image. Then go for the characteristics. Can anybody write the characteristics for this image diagram? Characteristics. Where is the object? Beyond the center of curvature. Where is the image? Where is the image? Location.
Between effects.
Yes, it is in between F1 and C1. Okay. Next size.
So diminished.
Diminished because it is smaller than the object. Then is it real image or virtual image? Real image or virtual image? It is real because I got this image by actual converging of light rays. So this is called real image. Real image, and the facing direction of the image is opposite to the object, called inverted image. So I can write the characteristics as followed here. The image is real image and it is inverted image. Then we will go for the size of the image. It is smaller than the object, called diminished image, and it is between F1 and C1. Okay, then we'll go for next position. Next position is here simply between, sorry, exactly on the center, at center of curvature, right? So at C2, then same process I am following, identifying. Let us place the object exactly on the center of curvature using the height width of the scale. Then draw the parallel light ray from the top of the object. Then second ray passing through the center, optic center, so that the behaviors already you know according to the situations. Complete them. Then here I am getting a converging point of these two light rays. From that point, I am drawing a vertical line onto the principal axis. So that point is converging point of top of the image obtained there. So here I'll get image at this point. So image characteristics I want. What are the characteristics of the image here? Is it real or virtual? Anyone? Is it real or virtual?
Sir, really.
Why you selected real?
Sir, because we did not extend any lines and we got with that same.
So
same
simply
rays.
by the converging of light rays after refraction, you are getting. After refraction it is. Okay. So that image is real image. We can see that real image on the screen. Then real image always inverted, or you can observe in this diagram also it is placed opposite to the object. Then position exactly, size same. Right? So these are the characteristics. Next position is object in between focus and the center of curvature. Focal point and center of curvature, whatever it may be. So complete it. Principal axis, pole, drawing the line, and making that as symbol for the lens. Then next identifying respective pole, focal points, then center of curvatures. Now object shown using the width of the scale, object height, right? Then draw the parallel light ray from the top of the object, complete its behavior. It passes through the focus. Then second ray passes through the optic center, remains undeviate. So where you get converging point, from there you can draw the perpendicular onto the principal axis. That point and that line is called image for you. That image size is greater than the object size, then it is enlarged image or magnified image. Then the position is beyond the center of curvature C1. Next, it is given by the actual converging light rays after refraction, called real image. Real image always inverted image. So I can write the characteristics as real image, inverted image, enlarged image or magnified image. Then finally I got this image beyond the center of curvature. Any confusion? Go to quick reaction. If there is any confusion, immediately take that reaction negative. So no confusion, right? So we'll go for next situation. Situation number 4 it is, right? So we place the object. We place the object where, just a minute, I will remove this. Okay, let us continue. So here, continue that process, identifying the pole, drawing the lens, then identifying the F1 and F2, C1, C2 respectively, then place the object at focus, right? From the focus, you need two rays parallel to the principal axis and passing through the focus after refraction. Then one more ray, optic center. Through optic center remains undeviate. So in front of the, sorry, that this direction, refracted light rays, they can meet each other. How they are appear? They appear to be parallel to each other. If you go in backward direction also, they remains parallel. So in this case, what are the characteristics we can write here? Simply the image is real image and the size is highly enlarged, we can write, and it is inverted image. Then finally position is at infinity, because I am unable to reach the position of a image by extending these light rays. Is it possible to reach? Parallel light rays never meet. So these are the characteristics of the image obtained by the lens, right? By the phenomenon refraction. Object position is at focus. Then we'll go for the next position. That is here, object placed. Object placed. Just a second. This animation not given, I think, for these lines. That's why it is coming like this. Just a second. Just look at that ray diagrams in your textbook. Thank you for your waiting. Right here, we'll look at that from the beginning. So here, simply, I got so position is exactly between F and P, or pole and focus. Object is shown, right? So now I required two rays. What they are? One is parallel to the principal axis and the other is passing through the optic center from the top of the object. One is parallel to the principal axis. We know after refraction, it passes through the focus. Then secondary, it passes through pole and remains undeviate. So how they appear to you? Do they appear as converging rays or diverging rays after refraction? Answer me. Do they appear as converging rays or diverging rays after refraction? That gap is increasing between the refracted light rays or remains same or decreasing. What you notice here, the gap between them. Am I audible?
Increasing.
Increasing. The gap between them increasing. So here they never meet if you extend them in the forward direction. So what we'll do in this case, we can extend them in the backward direction. See here, I'll get the image at that point. Right? So this is image for me. How I got that image? That image I got by the backward rays, extending the refracted light rays in backward direction. Then they will meet at a common point. That common point will give you the image of object. So that is image. So here, do you get image by the actual converging of light rays? In this case, no. By backward rays we got. Right? Backward rays, I got image. Right? So backward rays giving image in this case. So this type of image is virtual image. This type of image is what? Virtual image. So we can write the characteristic size virtual image. Virtual image always erect image. Then object faced eyes like, sorry, image faced eyes like the object. So that image is magnified image and erect image. Then position is beyond F2. Position is beyond F2, between C2. Maybe it changes depending on the focal length. Right? But it never go beyond center of curvature. It is always beyond F2. Is it clear, ray diagram? Everyone, how to draw the ray diagrams completed to the convex mirror. Now we are moving to the topic concave mirror ray diagrams. Before going there, I will generalize these observations what I got as a table, right? So here, just recall your knowledge or observe the ray diagrams given in the textbook, page number 68 and 69, right? So here, I know the position of the object and I am able to identify the position of image and we are able to write the characteristics of the image. Is like a real, inverted, right? And one more is diminished or magnified. So that characteristics we can write. So what is the position? Very first position is at infinity. If I place the object at infinity, what is the position of image given by the convex lens? That is here at focal point. What are the characteristics we are written? That is here point image, right? And we are unable to write anything here because point image, position only. Here we don't know size, point size only, and we don't know that facing side, above or below. So you are unable to say it is as inverted or an erect. Okay, so it is real image. Then at F2, right? If I place the object at F2, image obtained at focus, sorry, infinity. Image obtained at infinity. Then characteristics, what we are written here, it is simply written as, sometimes we are showing nothing, right? Or you are able to write like this also, highly enlarged, highly enlarged. It is real and inverted, but in your textbook, they are nothing given, so you can leave it, no problem. It is given in the last page, what we have learned. The table is given in the last page. So next position is beyond C2. If I place the object, I got the image between F1 and C1. Then Characteristics, it is inverted, diminished, and real. You can follow the ray diagrams, figure number 14, right? Then I'll go to the position between F2 and C2, right? So here, if I place the object between F2 and C2, image will be beyond C1. Characteristics, inverted, enlarged, and real image. Then object placed at center of curvature, image also at center of curvature, size is same, real inverted. Then object brought to the between pole and focus. Then image is beyond F1. Beyond, sorry, here F2 and P, beyond F2, okay, correct. Then image characteristics, virtual, erect, enlarged. Are you following? Sir, why you are taking this random direction, sir? Why not following same positions? Infinity, beyond, at, between, at center, and between P and F. Why not maintain? See here. I will show you why I give you. Suppose object is placed at infinity, where I got a object image at F1. So object at infinity, image at focus. If object is at focus, image brought to the infinity. They are linked or not? They are interlinked or not? If object at infinity, image at focus. If object at focus, image will be infinity. So opposite. Is it clear why I maintain these combinations? Right. The next, if I place the object at center of curvature, no change, at center of curvature only. Then look at here, beyond. I got between. If I place the object beyond C2, image brought to between F1 and C1. If I maintain the position between F and C, image beyond. Is it clear? Is it clear? I am linking. If you place the object between F and C1, image beyond C2. If you place the object beyond C, it will be between F and C. Right? Any number. Then remaining position is, this is only the case where you will get virtual image. Remaining all the situations given by the convex lens is real image. Everyone clear about these diagrams? Just speak out. Talk to me. If anything, nothing. Nothing. Shall we move to the another topic? Right. So these are the characteristics generalized for the respective positions of the object in front of the convex lens on the principal axis. Right. So now the topic is changed. That is ray diagrams of a concave lens. What are the various positions possible in this case? Concave lens, same positions. At infinity, beyond center of curvature, between at center of curvature, between center of curvature and the focus, and at focus, then between pole and focus. So these are the possible places, right? So here, individually we can observe, right? Individually we can observe what happens if you change the position of object in front of the concave lens. So here I'll show you the positions. So infinity we cannot show the object. At we can show the object. Beyond we can show the object. Between we can show the object. At focus we can show the object. Between. So all these positions are possible or not? Right? Sir, మాకు బుక్కులో ఇవన్నీ డయాగ్రామ్స్ ఇయలేదు సార్, మీరన్నీ ఎందుకు చెప్తున్నారు సార్? చూద్దాం, నేను లాస్ట్ లో మాట్లాడతాను. రైట్? ఆర్ యు హ్యావింగ్ డౌట్? అభినయ్, శ్రీచరణ్, కౌశిక్, విక్రాంత్. ఏమన్నా డౌట్ ఉందా ఇట్లా ఎందుకు చెప్తున్నానని? సార్ బుక్ లో మాకు ఇవ్వలేదు సార్, మీరు మాత్రం చెప్తున్నారు, మేము నేర్చుకోవాలనా? నేర్చుకోవాలి, బట్ we will give generalization at the end. So look at here. Now I placed object at infinity, so I cannot show the object. Only I consider parallel beam of light rays. In this case, just we will follow the same logic. They appear to diverge from this focus, right? So here image will be obtained by the backward rays called virtual image. So I can write the characteristics eyes like this here. Characteristics of the image are simply here it is virtual image, erect image, right? So here actually you need not to write erect image because here there is no height maintained or given by the image here. So keep blank only for one situation, that is infinity. Then remaining characteristics we can write point size and it is at F1 focus. So these are the characteristics. Why it is virtual? Because by the backward rays I got, not by the actual rays converging point. By the backward rays I got image. That's why I am writing virtual image. Where I can see this virtual image? On the surface of lens. It cannot be obtained on the screen, right? So then the second position is object placed beyond the center of curvature on the principal axis. So here concave lens I am drawing, same logics I will follow, 4 centimeters, 4 centimeters gap, right? Then showing the object just beyond the center of curvature, having the width as height. Then draw the parallel ray first from the top of the object. Second ray passing through the optic center. So here, why I connected these two, point of incidence and focus? Can anybody? Why I connected? I taken one ray from the top of the object. So without any explanation, just I connected these two. It is point of incidence and focus connected or joined. Why? To obtain refracted light ray. This meets situation 3. Situation 3. After refraction, it appeared to diverge from the focus. So from the focus, I am extending that light ray after refraction. See here. From the focus to the point of incidence, use dotted line. Then after that, you can draw the light ray. Clear this logic? How to expect that refracted light ray? After refraction from the concave lens, it is you are following logically. Then second ray, undeviate, remains undeviate. So here, after refraction, that refracted light rays are going to meet each other. They can converge. If you extend, they cannot. So they are diverging. So here in the backward direction, they can converge. Already I got the converging point. Where? Here it is. So from this point, I can draw a vertical line onto the principal axis. So this line is what? Image. I got image. So this is image for us. So here image is faced like object or not. So that is virtual image and erect image. So I can write the characteristic size followed here. Virtual image, erect image, because face is same as like your object above the principal axis. Size is smaller than the object. Then position is between pole and the focus. No change in the characteristics. Then we'll go for the next situation. What is next situation? Placing the object at center of curvature. So object placed at center of curvature on the principal axis shown like this. Shown like this. So here I got the position. Then completing the rays. So first ray parallel to the principal axis. Same logic you can follow. Connect the focus and the point of incidence. Then extend the light ray after refraction in the same direction. Then second ray. Right? Remains undeviate. Next, draw a perpendicular onto the focus, so principal axis from the point where you obtained by the diverging light rays, right? So here it is. Then what are the characteristics? Can anybody write the characteristics of image obtained here? Anybody? Abhinay,
Sir,
characteristics.
sir, it is a virtual image.
Why virtual?
Sir, we got image by extending.
In backward direction, right?
Yes, sir.
Not by actual converging light rays. So it is virtual. Then virtual image always
Sir, erect.
erect image. What about the size of image here comparing with the object?
Sir, diminish.
Very good. Then position.
Sir, between F and P.
Okay. So I got
F1 and P.
characteristics. I got the characteristics. Then we'll go for the another situation. What is the situation here? Placing the object between focus and the center of curvature, right? So I place the object here between focus and the center of curvature. Then complete that rays, two rays parallel to the principal axis, connecting the point of incidence and the focus, then extending in the forward direction. That is refracted light ray. Then second one, optic center. Through the optic center from the top of the object remains undeviated. So in this case also they never meet diverging light rays. So diverging point you will get. From there you are drawing the perpendicular onto the principal axis. Then we will write the characteristics. Eyes here, virtual image, erect image, diminished image between pole and the focus. Then position of the object changing now to the focus, right? So here at focus, I place the object on the principal axis, right, of a concave lens here. Then parallel ray, connect that point of incidence and focus, extend it, no change in that behavior of light ray. Then second one, passing through optic center, remains undeviated. So I got the diverging point that connected with the principal axis with a line. Then it is image for us. Then image characteristics are virtual, erect, then diminished and between pole and focus. Then object change it to now between P and F1. Object now place it between P and F1. So here top selected one ray parallel to the principal axis, connecting the point of incidence with the focus, then extending that to get the refracted light ray. Then second ray passing through the optic center, no change in that behavior. Then I got that diverging point by that refracted light rays. That point is connecting with the principal axis, that is perpendicular. Then it is image for us. Then the characteristics of the image are going to be like this: virtual, erect, diminished, between pole and focus. What you noticed here? Anybody? I drawn 6 positions ray diagrams. What you noticed here? What you noticed here? See, I am changing the position of the object very quickly. Observe that image. Are you following me? Are you observing your screen? Give me your quick reaction. Just focus on the screen. You will see the position of object changing, right? Randomly. So here, object now beyond, I brought it here to the object center of curvature. Next, it is between C1 and F1, between between P and F1. So I'm changing the position quickly. What about image? Characteristics are changing, remains same. Observe that. Characteristics are changing, remains same. Observe that. I am changing the position quickly. What you see here? Anybody give me your observation? Give me your observation. Tell me your observation fast. No time.
Remains similar.
Image is not changing.
Images? What not changing? Image position also changing. But always it is located where? It is located Kaushik,
Between
virtual.
reference.
Position always fixed. And type of image also same. It is what? Virtual, erect, diminished. So any change in the characteristics of image formed by the concave lens for any position?
No, sir.
No change in the characteristics of image. No change in the characteristics of image. So here simply that characteristics are what here? For any position, you are obtaining the characteristics of image obtained by your lens, concave lens is fixed. Right? Irrespective to the position of the object, concave lens always forms virtual, diminished, erect, and the position is between pole and the focus. Do you agree or not? Do you agree or not? Yes. So, no need to remember the characteristics of object position and characteristics of the image respect to lens. If you follow these logics, respect to any lens, irrespective to the position of the object, you will get the characteristics fixed. What required or what it will give you practically, that only you will get. Right? So once try today. Right? Once try today. Don't follow your textbook, just follow my logic rules to draw the ray diagrams. Then you can complete the ray diagrams. Then compare the diagram with your textbook diagram. Clear? Give me your quick reaction. Right. So how do you feel today's class, Surajita?
Sir,
What about ray diagrams? Clear? Or any confusion?
sir,
So once
sir,
try
no. Okay,
by following the same tricks. Sri Charan,
okay.
Sir,
ray diagrams.
sir, interesting, no doubt.
You need to prepare the ray diagrams again.
No, sir, no need.
No need. Vikrant,
Sir.
ray diagrams. Will you draw?
Yes, sir. Understood.
If I give you any situation immediately, are you able to draw?
Yes, sir.
Yes. Abhinay,
Sir,
have you feel any difference
sir, no, sir.
learning the ray diagrams?
Understood very well. Sir, no, sir. But I understood very well.
Very good. Medhasri,
Yes, sir.
clear?
Yes, sir. Clear.
Tejaswini,
Sir, clear, sir.
yes. Kaushik. Kaushik.
Sir,
What about ray diagrams?
so clear.
Clear? So
Yes.
take your own situation. That means position of the object, any lens. Draw the ray diagram by these logical rules and complete it. Compare them. Finally, compare with the characteristics given in the table. Right? So this is today's class. We'll join tomorrow at same time. Thank you.